I'm going to draw a rectangle for this first part just to get a feel for what's going on. So it's got length 4x and width x plus 3. It doesn't really matter which you label which. And we're told the area is less than 112. So, then it says write down and solve an inequality to work out x. So the area is going to be 4x times x plus 3. And I'm told that this is less than 112. So I've constructed my inequality. Now you could expand this and divide by common factors later, but actually probably best to divide by 4 now. And 4 will go into 112. You only actually have to look at the last two digits to see if a number is divisible by 4. And if those last two digits are divisible by 4, the number will be. And if it's not, then it won't be. So 4 goes into 12, so this will definitely work. So 4's into 11 go twice, remainder 3. 4's into 32 go 8. Therefore, x plus 3 is less than 28. Expand the bracket, x squared plus 3x. I'm going to also minus 28 from both sides to get less than 0. This is how you deal with quadratic inequalities. You deal with it in the same sort of way as when you solve quadratic equations. And in fact, the solution process is then to try and find the roots. We're going to find where it crosses the x-axis, and that will allow us to draw a curve from which we can see where it's less than 0. So two numbers that multiply to give minus 28 and add to give 3. It's going to be plus 7 and minus 4, which gives me roots of minus 7 and 4. Technically, the turning point is going to be before the y-axis, so I just drew it in. Accurately, it doesn't really matter. And we're interested in where it's less than 0. Now, it's less than 0 here, below the axis, and it's the values of x we're interested in for that. So it's going to be minus 7, less than x, less than 4. Now, you might think, oh, that's the solution. But you've got to be really careful because we're not just solving a quadratic inequality here. We are solving a physical problem. And so the lengths, and we could have maybe have said this right at the start, the lengths have to be greater than 0. It doesn't make any sense for the rectangle to have a length of 0. It's got to be greater than 0. And so actually we have to reject all the negatives. And x equals 0. So 0 is less than x less than 4. Very easy to just rush through this question and miss that. It's got to be said. All right, we've now got a second inequality. Sorry, I was just trying to copy the question. Here we go. Bring it down here. Second rectangle tile of 4y and width y plus 3. And it's had a rectangle of length 2y and width y removed as shown. Given that the perimeter is between 20 and 54. Okay, I'm just going to set that up as an inequality. Determine the possible set of values of y. So the perimeter, right, we need to make sure we got all the sides. So I'm going to label them. So because this is y plus 3 and this is y, the difference is just 3. This must be 3. And this longest length over here is 4y. This is 2y, so that must also be 2y. And now I've got all the lengths. So I'm going to imagine I'm a little person and I'm walking around the shape. Okay, first I'm walking y plus 3. Then I'm walking 4y. Then around here, 3 plus 2y plus y plus 2y. And I'm back to the start. Add all the y's up. That's going to be 5y, 7y, 8y, 10y, 10y plus 6. And now I've got my inequality. 20 is less than 10y plus 6, which is less than 54. When you have inequalities like this, it's more complicated if you had, say, y on the left-hand side as well and on the right-hand side, but not so bad here because we can actually do the same, as long as we do the same thing to each part, we're okay. So if I'm minus 6 from each part, I'll get 14 is less than 10y, which is less than 48. And now I can divide through by 10. 1.4 is less than y, which is less than 4.8. Okay, that was neat.